Hello everybody, welcome back to another Miss Pollard Math YouTube video. Today we're going to be going over geometric sequences, and these are very important to be able to see what the term is going to be inside a sequence. So sometimes they might ask you to find the 100th term, and it's like, how am I going to find 100 numbers out? Thankfully there's an equation and we're going to look into that. So something that's important though is to think about. There's arithmetic and a geometric sequence, and we're like, what is the difference between the two of them? Well, arithmetic sequence is when we're adding to each of our values, where a geometric is where we're multiplying. So we're going to focus on the multiplication, but you should always check. They might ask you, is this arithmetic sequence or a geometric sequence? And you're going to have to check, is it going up by addition or is it going up by multiplication? Once again, if it's going up by multiplication, it's going to be a geometric sequence. So the formula for a geometric sequence is an equals a1 r to the n minus 1. And a lot of these are like, what is this talking about? So this means the nth term. So whatever term you're looking for is going to be here, equals the first term times our rate to the term we're looking for minus 1. And what this all means is the rate is the number we're multiplying by. This is our starting numbers, the first one in our sequence. And let's say we're looking for the 20th term. I plug 20 in for n minus 1. And when I evaluate this, when I use my order of operations, whatever answer I get is going to be this term. So this is the term we're looking for. This is the number of the term we're looking for. So example, the 20th term. And we just plug everything in to be able to solve. So let's apply this and see how we would complete this. So we want to create a geometric sequence and find the 23rd term of this. So we have to look, is this geometric? Is it arithmetic? Obviously it tells us it's geometric, but we look. This is going up by 13. This is not going up by 13 by addition. So it's not arithmetic, it's geometric. So I'm going to see, what am I multiplying by? So for here, we are going by times 2. Same thing here, times 2. Times 2. And some of you are like, well, I'm looking for the 23rd term. I could just multiply 13 by times 2, 23 times. Well, that's just going to take a lot of time. We don't have that much time, especially when you're taking the SATs or any type of time testing. We don't have the time for that. What if they ask you for the 1,000th term? We don't have time for that. So we are going to create the equation. So my 23rd term, so my A23 is going to equal my first term. My first term is 13 times my rate. My rate is 2. I am multiplying by 2. So I'm going to multiply by 2. And then it's to the n minus 1. Well, I'm looking for the 23rd term, so my n is 23. Minus 1 is 22. And then we just put that in my calculator. So I'm going to put 2 to the 22nd power times 13. And I get a very long number, which is 5, 4, 5, 2, 5, 9, 5, 2. So as you can tell, it's a big number. We are not going to want to multiply by 2, by 2, by 2. Do you see how crazy it gets? It's easier just to plug into this formula. And a lot of times on our standardized testing, they give us the formula. So you just have to look at the formula and know what it is telling us to do and plug in. Now we're here. We want to create a geometric sequence and find the 8th term. So I'm going to look. Once again, we're subtracting, then we're adding. It's not arithmetic. They tell us it's geometric. I'm looking. I am multiplying by -5, by -5, by -5. So my rate is -5. So I'm going to write my equation. I'm looking for the 8th term. My A8 equals my original, which is 1, times my rate, which is -5, to the 8 minus 1 is 7th power. I'm going to put the -5 in parentheses because sometimes when we don't do that and plug it into the calculator, it acts like it's 5 to the whatever power times the negative. In this case, that would be fine because we have an on, but what if it's an even? So I'm going to do -5 to the 7th power times 1, which is just what it is. So that gives me -7, 8, 1, 2, 5. Once again, you're like, I could just multiply. What if I give you the 1,000th one? You don't want to go out 1,000 times, right? All right, now we want to create a geometric sequence and find the 25th term. Well, this one's a little bit tricky. This is not just multiplying by 2 or multiplying by 5. So we look, I'm going to do 10 divided by 4. That gives me multiplication of 2.5. You can leave it as a fraction, I'm going to leave it as a decimal. 25 divided by 10 is also times 2.5. And this one's going to be as well. So I'm now going to plug it into my equation. My 25th term equals my original times 2.5, or 5 halves, to the 25 minus 1, which is 24th power. So I put in my calculator 2.5 to the 24th power times 4. And that gives me a huge number. So I get 1,4,2,0,8,5,4,7,2, and that's 1, 2, 3, 4, 5, 6, 7, 8, 9. There's one more 10. So that would be my answer. When I plug it into my calculator, I got this huge number. It told me 1.42 times 10 to the 10th power. I had to move the decimal place over 10 times. You see, we do not want to have to multiply each time by 2.5 times. That's going to take us too long. This is a shortcut. So this is how we apply the geometric sequence. We're now going to step it up a little bit. So let's take a look at that. So now we are given a term in our geometric sequence and our common ratio, our rate. And we want to find the first term and then find the 13th term. So what I'm going to do is I'm going to plug in what I know. My A3 is negative 36 equals, I don't know what my A1 is. I'm looking for that. My rates, or my common ratio, is R, so times 6 to the, my N is 3, so 3 minus 1 is 2 to the second power. We did 3 minus 1, so it's N minus 1 as our exponent, so I did 3 minus 1, which is 2. I get negative 36 equals A1 times 6 squared is 36. I'm solving for A1, so I'm going to divide by 36. And I get my A1 is negative 1. So even if they do not give you what your A1 is, you're able to figure it out by plugging in information that they give you. So my new equation is going to be AN, my nth term, equals my first term times, it says my rate is 6, my ratio, and minus 1. But now we want to find the 13th term, so I need to plug in my information. My A13 is going to equal negative 1 times 6 to the 13 minus 1 is 12. I'm going to put that in my calculator. 6 to the 12th power times negative 1 gives me my 13th term is negative 2,1,7,6,7,8,2,3,3,6. And quick, easy shortcut to be able to find the 13th term. Let's step it up one more time and see how we can apply it in an even more abstract way. We are now given two terms in the geometric sequence, and we want to be able to find our original term to create our original equation and then find the new term that they're looking for. So a way that we can do this is we have to substitute, basically. So my A5 is 324. We are going to act like almost like this is our first term. We're going to see how far away we're going. We're going from this term to this term. So this is my new term, and we're going to kind of act like that's the original for a second to be able to find what that true original is. We're really finding the ratio right now to then find the original. So let's see. 324 equals, my A3 is 36, times, I'm trying to find my R. I am now going to do, we are not doing minus 1, right? We're not taking my number and subtracting 1 like we're used to. I have my 5 and my 3, so I need to plug that in. I have my 5 here, because that's what my N was. Every time, like this was A13, I did 13 up here. Now we subtracted, this was A1. Now I'm going to subtract what I'm working with, which is A3, so I'm going to subtract the 3. So I can write this up a little bit better. AN equals A1 times R to the N minus 1. I had my N here. I had my N here. I had my 1 here. I had my 1 here. So I use my A5 here and my A3 here, so I have to do 5 minus 3. And then I can solve this to find what my common ratio is, what that rate is, and then continue. So 5 minus 3 is 2, so I get 324 equals 36 times R squared. I'm going to divide that 36 over, and I get 9. So 9 equals r squared. When I square root that, that gives me positive or negative 3. So my r is either positive or negative 3. For this instance, they would have told you whether to use the positive or the negative. They told me to use the positive. I know it doesn't say there, but when I was creating this problem, I had in hopes that we were going to use the positive. So we're going to use the positive. So I'm going to plug in what I know. 324 equals my A1 times, I'm going to use the 3 because they told us to use the positive, to the 5 minus 1. So I get 324 equals A1 times 3 to the 4th. 3 to the 4th is 81. So 324 equals A1 times 81. Divide that 81 over, and I get my A1 is 4. So now my final equation, took us a little bit, my final equation is my nth term equals 4 times, we found the rates is 3, to the n minus 1. Now they're asking for the 12th term, so let's plug that in. So my 12th term is going to equal 4 times 3 to the 12 minus 1, which is 11. So 3 to the 11th power times 4 gives me my 12th term as 708588. And once again, if they said it could be the positive or negative, when I square rooted it for my ratio, I would use the negative as well. So you would give me 2 answers. If they don't tell you if you're using the positive or the negative, you would give 2 options. So I could also do the negative 3 to the 11th power, and then times it by the 4, and it would give me the negative of this. So it would be plus or minus this as the answer. If they didn't tell you which one to use, they have to clarify which one to use, or you wouldn't be able to do this. So I hope this helped with your understanding of geometric sequences.